Hello Year 3 and Year 4. I hope you are well and ready for the next science session on states of matter. I've been so impressed by your learning on the water cycle and the lovely pictures you sent in of your investigations. We also had some great observations and conclusions. You realised that the water was evaporating to vapour, cooling down and condensating on the side of the bag and then returning to the bottom. Well done. Today, we are continuing our learning on states of matter and we are going to be doing some classifying. So what does classifying mean? We have a definition here that classify is a verb and it means to arrange a group of people or things in classes or categories according to shared qualities or characteristics. So today we are going to be classifying or sorting objects as to whether they are a solid, a liquid or a gas. Let's have a closer look at what those words mean. So here we have solids. These items are all solids and we can see that we have a tin can, we have some rocks, a magnet, some ice and some Lego. We also have some sand and some sugar. So what do they have in common? Materials in a solid state keep their shape unless a force is applied to them. Solids can be cut, squashed or twisted. They will not change shape on their own. Solid materials always take up the same amount of space. They do not spread out or flow. Solids do not have to be hard. They can be squashy or soft. So even though we have the sand that can spread out, don't forget the sand is made up of lots of teeny tiny pieces or solids that don't change shape. Now these items are all liquids. So we've got some lemonade, we have some milk, some cola, honey, that's some soup there, a cup of tea, and here we've got some rain. And what do they have in common? Materials in a liquid state take the shape of the container they are in. So here we have the milk and it's the shape of the bottle that it is in. And although liquids can change shape, they do not change their volume. This means they still take up the same amount of space. Liquids are pulled down to the bottom of a container by gravity, and liquids can flow or be poured. And lastly, let's have a look at some gases. So we have the hot air balloon here, and we have some bubbles. We have some steam coming up from a kettle. We have somebody breathing in the air. Materials in a gaseous state can spread out to completely fill the container or room they are in. Gases have weight, gases can be squashed, and gases do not keep their shape. Okay, so here's a little activity for you. Can you match the properties with the correct state? So we have solid, liquid and gas, and then we have some sentences. Can you put them in the right order? So we have spreads out to fill a space, keeps its shape, can be cut, squashed or torn, takes the shape of the container it is in, can be poured, and does not have a fixed shape. So do you think spreads out to fill a space should be for a solid, a liquid or a gas? Pause the video and have a go, and then we'll have a look at some answers. Okay, so here are the answers. How did you get on? And here is today's activity. So on the assignment, you should have a worksheet that looks like this, and you will also have a document that has some pictures. There are actually 4 pages to the pictures, but I've just put 2 here to show you. And what you have to do is to sort these items into whether you think they are a solid, a liquid or a gas. So do you think that a brick, for example, should be a solid, a liquid or a gas? So you could just write in what you think, or if you can print the pictures, you might be able to cut them and stick them on if there's room, or maybe even draw them. It's absolutely fine. So that's today's task, but before we finish today, I would like to give you a sneak preview of what we'll be looking at next time. Next time we'll be looking at the differences between solid, liquids and gases by finding out what they are made of. Scientists have found out that all materials are made of very tiny particles. These particles are so small that we cannot see them with our eyes or even with a microscope. The position and behaviour of these particles is different in solids, liquids and gases. So here are some pictures of the particles to get you started. Which of these pictures do you think represents a solid, liquid and a gas? Is it possible for a material to change state? What do you already know about materials changing state? Okay, if you would like to have a go at investigating how materials change state, here's an activity you can do before the next session. Now, if you don't have these things at home, please don't worry. I'm going to do this experiment. I'll show you it in a moment and I will share my results with you next time. So only do this activity if you have time and you have the materials. So for the activity, you will need a bottle, some vinegar, bicarbonate of soda and a balloon. You will also probably need a grown-up to help you. So first of all, you pour some vinegar into the bottle. I used white wine vinegar, but it doesn't matter what vinegar you use. And you can see I put in maybe 2 or 3 centimetres in the bottom of my bottle. Next, you need to put some bicarbonate of soda into the balloon. Now, if you have a funnel at home, that does make it much easier. I didn't have a funnel, but I put it in this sort of plastic jug and managed to tip it in. If you inflate the balloon slightly and then let the air out, so it's had a bit of stretch, that makes it easier as well. I put in maybe just under a teaspoon of bicarbonate of soda, but it doesn't matter too much. But a teaspoon is about right. And then what you need to do is you need to put the balloon over the top of the bottle and let it hang down. So you can see there that I fitted it over the top of the bottle. Try not to leave any air gaps. And then you flip the balloon up so that the bicarbonate of soda falls into the vinegar. What happens next? Now, as I say, I'll share the results of what happened next when I tried this next time. But if you wanted to send in any pictures, if you do this experiment, then that would be fantastic. Do have a camera ready, I suggest, because things do happen quite quickly. Okay, so that's it from me today. I hope you've enjoyed the science learning and I'll speak to you soon. Goodbye.